Okay, the last type of compound for naming compounds are acids. So hopefully we can get through this, and this one's the one that requires a little bit of work because you guys are not used to polyatomic ions right now. Maybe we can help memorize them, or we just have to work at them. So a lot of this has to do with understanding the previous rules and also just working with the polyatomic ions a little bit more. So if we look at this basic little chart I drew up here, it's a quick reminder of everything that we've covered so far. So what we're going to look at is highlights of this chart are the different types of compounds and what each one begins with. So, and ends with. So we're looking at begins with, ends with. And this should help you it should help you somewhat with helping identify how to name certain things. So ionic compounds always begin with a metal. And they will end with a nonmetal or a polyatomic ion. And that's what we saw last week. And then with these metals, too, the only other thing that you can start with, other than a metal for an ionic compound, would be NH4, which is ammonium, which is a polyatomic ion. But I didn't want to put polyatomic ion or a metal, but NH4, ammonium, is another one. Now, molecular compounds are the easiest ones because they begin with a nonmetal and they end with a nonmetal. So you just have to be able to look at a periodic table to discern between the two. Acids are very unique. Now, this is not true for everything, but most inorganic acids, there are organic acids that are a little bit different, but most acids begin with H. So it's not always true, but for our naming purposes right now, all acids begin with H, and they will end with a nonmetal or polyatomic ion. So the big thing for an acid is for right now is if you see a hydrogen, it's an acid, and that's how we're going to name it. Everything else we can work with, but then we're going to mix all these things together. So the first thing we're going to do is talk about if we have this hydrogen, how we can name the substance. So moving on to the next thing is the first type of acid is a binary acid. And with a binary acid, you see the bi prefix again, which means 2. So binary means 2, so you're going to have hydrogen and a nonmetal. Now, when we're doing this, if you see hydrogen and a nonmetal, it will start with the term hydro. And I have to clear this up. This hydro does not stand for hydrogen. That hydro stands for in water, hydrated. And that's where you see down here where I'm underlining these AQs. Okay? You'll see that prefix. That means aqueous. That means dissolved in water. We'll come back to that later, but that's a discernible fact for this. So if we know that, if we see that AQ, we're using the term hydro or the prefix hydro. The next step would be the non-metal name. So we can go through the first one. HBr, AQ. We're going to use the prefix hydro. Br is bromine, so we're going to use bromine, but we're not going to finish bromine because we use the non-metal name, but we have to change the ending to ic. So instead of bromine, we have bromic, and then we add the word acid. So you can see I use the word hydro, the prefix hydro, the non-metal name, change the ending to IDE, and then you add the word acid. Next one you're most familiar with, you probably heard this one before, but you have HClAQ. So we have the hydro. Then it's chlorine, but it becomes chloric. So it's hydrochloric, and then the word acid. So we have hydrochloric acid. So when you look at this, please make sure you just review that. I would go back and look it over one time. But binary acids are kind of really easy. Just real quick, sometimes you'll see an AQ versus a G. G stands for gas. And if you see the G, you name like ionic compound. So you name it like an ionic compound. And we have HCl, which we saw on the previous page because we have the AQ here. So that one is hydro, we just did this one, chloric acid. And that's because we have the AQ there. Now, if we have a G there instead for the gas, that means the gas, it's not dissolved in water. And we name it like ionic. So if we were to name this like ionic, it would be hydrogen chloride. And sometimes you'll hear the word hydrogen chloride gas used. So whenever you see the G, you don't do this. You have to make sure you see the AQ in order to name it that way. If you see a G, you're using ionic rules. So make sure you go over that. One other aspect that we'll do is we're going to mix all these things together at the end. So please make sure you're aware of that. Now, oxyacids. Oxyacids are hydrogen plus a polyatomic ion. Big thing, no hydro. We don't use the hydro prefix. And you'll see why later on. We're going to use the polyatomic ion name, but again, we have to change the ending. And this is where it can get complicated because when you change the ending, it depends on what the original ending is. So, for example, when you change the ending, there are two sides to the same coin. If you have ate or "ide," if you have ate or "ide," it will become "ic," and you add the word acid. So, for example, right here we have hydrogen. We know that it's an acid. That's where we're getting the word acid from. That's the hydrogen part of it, so we're going to write the word acid. Now, we're going to use this polyatomic ion name. That is nitrate. But because we change ate to "ic," it's nitric acid. So that's the name. The hardest part is you have to take the time to know that it's nitrate to change it to "ic." The opposite side of this is if it's "ite," you change it to OUS or OUS or OS. So this is nitrite on this side, and you have a hydrogen attached, so that is acid. But "ite" becomes us, so instead of nitric acid, it's nitrous acid. I don't know why. So it's nitrous acid. So nitrite becomes nitrous. Now, here are some more examples. What you should do right now is pause the video and see if you can name these. And then after you see what I name them, kind of go back, rewatch, and see how you do this. Okay, so the first one, after you've paused it and tried them on your own, this is SO4 is sulfate. Okay, so this is something you'd have to, some of you may have written sulfic acid, but one thing that we will learn is that sometimes there was a name already established, and this one is known as sulfuric acid. It's just something you kind of have to go with. Now, PO3 is phosphite. Phosphite means that we change it from, it's not phosphoric acid, it's phosphorus acid. Okay, so we have to change it from phosphate or phosphite to phosphorus. Now, CN is cyanide. Ide becomes ic, so it's cyanic acid. And then the last one on here, chlorate becomes ic, H becomes ic, so it's chloric acid. Okay, and then the last thing we're going to do is we're going to mix all the binary and oxyacids together. And we're going to do that. Okay, so here's a list of some examples of everything mixed together. And what I would like you to do again is try these out and then come back and see what names I put on them and then ask questions. So it's okay to contact me about any of these, and it's okay to go over any of these. So when we look at these, the first thing is we have an AQ situation. You'll notice all of them begin with H. And if there's an AQ, what you have to look at is once it begins with an H, is there a polyatomic ion or a nonmetal? In this case, if you notice, we don't need anything after them if there's a polyatomic ion. But since it's Cl, it's a nonmetal, and we have the AQ, so we know we need hydro. Cl is chloric. And because there's that H attached, we need the word acid. Now, the first two I did as an example of why the hydro prefix is used. Because the next one, we have chlorate. It's not a binary, but we have to use that polyatomic ion name, so it becomes chloric acid, because chlorate becomes chloric, and then the H tells me it's acid. This, because there's no hydro used at the beginning of this one, it tells me that it's the polyatomic ion and not the nonmetal. So that's why some rules have become the rules that they are. And now remember, if there's a G there, we name it like an ionic compound. So this would just be hydrogen chloride. If you want to add the word gas, you can. Now the next one, we have CO3 attached to an H. So we have to look at the polyatomic ion name. That's carbonate. So this becomes carbonic acid. And that is what's found in soda. So that's why it says carbonated soda or carbonated beverages. Last two for the day, and you have HClO2, chlorite. So we have chlorite instead of chlorate now. So this would be chlor, but we change the ending to us and add the word acid. And then the last one we have is PO4, which is phosphate. Notice we're not using the prefixes hydro on the last two. We're not going to use hydro here either. So this is going to be, instead of phosphate, it's phosphoric acid. So hopefully from looking at these notes and going over them and having access to them all, you'll be able to name these compounds. So please stay vigilant with it, and it's going to require some work. So you're going to see, like, we might take a break from notes for a little bit, and the last thing you'll see for this unit is what happens when we mix them all together and how to use a flowchart. So again, you're just going to have to review some things, and hopefully that works for you.